All right, so the other answer that was given is correct, but it doesn't actually answer the question, which is to find the limit, right? It's true that you can use a chain rule to actually find this derivative, but the question is evaluate the limit given this function. So that's what we're going to do here. We have the limit definition of the derivative, which is limit as h tends to 0 of f of x plus h minus f of x, all divided by h, right? And now we can just substitute our function for those values into the limit. So this is equivalent to the limit as h tends to 0 of, it's going to be the square root of x plus h squared minus 3. Apologies for the handwriting. Minus the square root of x squared minus 3, all divided by h. Now, this seems impossible to figure out unless you've seen problems like this before, because as we expand out x plus h, we can't really simplify this. What do we do with the square roots? How do we get rid of this h in the denominator? But there's a trick here. And the trick is that normally we want to move the square roots from the denominator into the numerator. But in this case, we actually want to do the opposite. We want to move the square roots from the numerator into the denominator. And the way we do that is by multiplying by the conjugate, right? So multiplying by this thing, but with the sign in the center switched. So that's what we're going to do here. I'll just copy paste this. Copy paste. And we just multiply by the same exact thing, but with a plus in the center. I don't have a lot of time to go through this calculation, but essentially as you FOIL this or double distribute it, you'll see that the middle pieces with the square roots will cancel out, and these first pieces will simply lose their square roots. So this will be equivalent to, we will just have, and this looks like it's in the exponent, but it's really not. This is just a function, remember. We're just going to have x plus h squared minus 3 minus x squared minus 3. And that's all just going to be over h times the square root of x plus h squared minus 3 plus h times the square root of x squared minus 3, right? Just by distributing that h over each of the denominator components. Okay, so if that's not completely clear what's going on here in the numerator, I apologize. Run through the calculations yourself, right? FOIL, distribute. Those square roots will drop off, the middle terms will cancel, and we will be left with this. Now from here, all we have to do is simplify. So we're going to we will distribute out the x plus h squared, and that's going to give us x squared plus 2xh plus h squared. And then we will have a minus 3 over here, minus x squared plus 3, right? And this is all going to be over this entire denominator piece. Now, just for the sake of time, I won't rewrite this, but we're going to simplify the numerator here. So x squared minus x squared is 0. These things cancel out. Plus 3, this should be, we distributed the negative in, so this is a plus 3. So these two things cancel out, and we're left with 2xh plus h squared, all divided by this entire denominator, right? H times the square root of x plus h squared minus 3 plus h times x squared minus 3. The h's will cancel, right? And we're left with 2x plus h divided by x plus h squared minus 3 plus x squared minus 3. And now, as you take the limit, you'll see that this thing cancels out, And what we're left with is we're just going to be left with the function. Let's see if I can get some more room. We're just going to be left with the function 2x over 2x squared minus 3. Those 2's will cancel, and we're left with x over x squared minus 3. I've run out of time, so hopefully this uploads. This is just gotten from taking the limit, right? As h tends to 0, the h's will cancel out. You can treat them as being 0, and then this is the function in the end. Thank you for watching.